Hello. In this Labtube, I will do an example about invertibility of matrices. And I'll show you how one can use elementary row operations to determine if a matrix is invertible or not. Let's see what the question asks. Find values of k for which 2k11, the matrix 2 by 2 matrix 2k11 is invertible. In questions like this, what you need to know is that to check invertibility, you have to form augmented matrix AI, and then you transform it to row reduced echelon form. So row reduced echelon form. If you can get to identity something else, that means your original matrix is invertible. If you can get there, that means A is invertible. Well, that's great. So here I have the matrix 2k11. And I form augmented matrix. So I have a 1, 0, 0, 1. And now I want to row reduce. I have to transform this to row reduce echelon form. OK, so I start from first column. Choose this entry to be my first leading one. I can choose 2 to be my leading one. I have to then divide by 2 row 1. But that would give me fractions. I want to avoid that getting fractions. So if I change row 1, row 2, so 1, 1, 0, 1, and then 2k, 1, 0. Then I have leading one in the right place. The next step is make everything else in that column 0. Here I have to make this 0. So to make that 0, I need to multiply row 1 by -2 and add it to row 2. So I have 1, 1, 0, 1. And you add, multiply -2, you add 0, -2, k minus 2, -2, 1, -2, -2. Well, the first column is good. I can go find the next leading one. The next entry which is there is k minus 2. When can I make that to my next leading one? To be able to make it to leading one, I have to have non-zero entry here. If I have 0 entry here, I'm done. I cannot make identity. But if k minus 2 is 0, then I have 1, 1, 0, 0, 0, 1, 1, -2. Yes, I have that. And as you can see in this case, I don't have any entry to make next leading one. And this is my row reduced echelon form. And that means in that case, I cannot get identity here. Well, I cannot get identity there. That means what? That means A is not invertible. So if k, solve this, k minus 2 equal to 0 means k is 2, then A is not invertible. What if k minus 2 is not 0? If k minus 2 is not 0, then I can divide row 2 by k minus 2 and make it my next leading one, and then use that to make this one 0. I will get identity. So if k minus 2 is not 0, That means I can get to I something else will be the row reduced echelon form. And being able to have ID means that A is invertible. So in this case, which is K is not 2, A is invertible. And that gives me answer. For every value of K but 2, I will have a matrix which is invertible.